Uh, Hello friends, welcome back to 5G series. So today we will discuss the frame structure, slot structure and numerology of 5G NR and how it is different from LTE. Okay, so let's get started. So in LTE, if you remember that just for a refreshing purpose, I'll give you a review. This is 10 millisecond. Okay, 10 millisecond is frame. Sorry, 10 millisecond is frame in LT, right? And if we further divide this into 10 parts, 1 2 3 4 5 6 7 8 9 10, whatever, suppose it is divided by 10, then 1 millisecond, it is called subframe. Sorry, it is called 1 millisecond is called subframe. Okay, fine. So this used to be the frame structure. Now in LTE, if you remember, if one subframe, right, one subframe used to have 14 OFDM symbols. Okay, divided by half, so 7 here, 7 OFDM symbol here and 7 OFDM symbol here. So total 14 OFDM symbols in one, and that is one slot. One slot used to be of 0.5 millisecond, because we further divided this 1 millisecond subframe into two parts. So one slot is 0.5 millisecond and having 7 OFDM symbols. So that is just the refresh of. And subcarrier spacing was fixed in 15 kilohertz. It was fixed in LTE, right? Okay, so now how it is different in NR, 5G NR. In 5G NR, what happens that it is the same. Okay, I'll draw it with this one. I'll draw it with the red part. So in 5G NR, the frame once 10 millisecond subframe, frame, that is the same as it was in LT. No, same here. And further, if we divide it into 10 parts, 1 2 3 4 5 6 7 8 9, suppose this is 10, then this 1 millisecond is called subframe. Here also it is same like LT, so it is called subframe. Okay, now in LTE, now if we expand this one subframe here, okay, now it has 14 OFDM symbol, and with 14 OFDM symbol, this is one slot. That is one difference in LTE and NR, that the one slot is 0.5 millisecond having 7 OFDM symbols, but here one slot is having 14 OFDM symbols, right? 14 OFDM symbols. And if it has 15 subcarrier spacing, 15 kilohertz, then it is 1 millisecond, just in case of it is 15 kilohertz subcarrier spacing. Okay, now this is 14 OFDM symbols. Right, now if you will see, there are numerologies, right? Numerologies, what I'll do, okay, if you have heard about, so this is broadly the frame structure and slot of, if we have the 15 subcarrier spacing in NR, right? Then this is the difference, that one slot is 1 millisecond having 14 OFDM symbol, one slot is 0.5 millisecond having 7 OFDM symbol. Now, okay, now you might have heard about the term numerology. What is numerology? Right, we can say that we are we have subcarrier spacing, right? So subcarrier spacing, we can define the numerology in terms of subcarrier spacing. So in NR, in LTE, right, in LTE it was fixed 15 kilohertz subcarrier spacing, but in NR we have flexible subcarrier spacing. So that is numerology. So that is 15 kilohertz, it may be 30 kilohertz, it may be 60 kilohertz, it may be 120 kilohertz, right? So these are the subcarrier spacing that is possible: 15, 30, 60, 120, and I think 240 is also possible. Not sure about that. So these are the subcarrier spacing. Now if you know that FR1, FR2, right, two frequencies are there, frequency band we can say. So up to so this 15 and 30 and 60, okay, 15 and 30, these three are used in FR1, and mostly these two are used in FR2. Sorry, yeah, FR2. Okay, so now what is the use of this, and what is the difference between these different numerologies? What the difference, or what the impact they have on we can say frame structure? Why do we have these? So let's see. These numerologies are why, because if we will see the frame structure, right, suppose we take one slot, I'll show you the difference. This is one slot of NR, so one slot means this is 1 millisecond, and suppose it is 15 kilohertz. Okay, 15 kilohertz means that it has 14 symbols. Suppose here 14 symbols. If we divide it 1 2 3 4 5 6 7 8 9 10 11 12 13 14, suppose these are 14 symbols. Okay, and one symbol has a particular, this is on time, okay, this is time axis. So there is a time for particular symbol, right? One symbol, suppose it has some particular time, any time. We can say that if I'll say, just 1 minute. Just a moment. Okay, now what will happen when we have 30 kilohertz subcarrier spacing, right? In 30 kilohertz subcarrier spacing, it gets, because here the subcarrier spacing is getting just double, so the time slot duration, the time slot you can say the symbol duration will just get half. It means, what does it mean? That in 15 kilohertz we were having 14 symbols in 1 millisecond, 14 symbols, but now with 30 kilohertz we will have 14 symbols, 14 OFDM symbols in just 0.5 millisecond. It means when the subcarrier spacing will get double, our slot size will decrease. Okay, earlier the slot size was 1 millisecond and we were having 14 symbols in 1 millisecond. Now with 30 kilohertz we will have 14 symbols in 0.5 millisecond. So what impact it has? That it decreases the latency, right? So we can say that if we want higher throughput of less latency, low latency, then we can go for higher subcarrier spacing. Now if further we will have 60 kilohertz subcarrier spacing, then further what will happen? That these 14 symbol will further be with further the size of the slot will further decrease to half of 0.5, means 0.25 millisecond, and these 14 symbols will come here, and this would be the slot size. So if we further increase the subcarrier spacing, the slot size will further decrease. Low latency, low latency, it means fast throughput. Low latency means fast throughput, right? And if we further increase the subcarrier spacing, then further it will just be half of 0.15. So how much it comes? The half of 0.25, it comes around 0.125. So it just half of this, and within this 0.125 millisecond 14 symbols will come. So the size of the duration of the symbols will further decrease, and this would be one slot. Okay, so lowest latency. So this is this is called numerology in NR. This is the difference between LTE and 5G, that in LTE 15 kilohertz subcarrier spacing is fixed, but in NR we have flexible numerology. So with increasing the subcarrier spacing, we can decrease the slot size and we can decrease the latency, and we can if we decrease the latency, obviously the throughput will increase, right? So this is one main concept, that's the difference between LT and NR structure, frame structure. Okay, and now right, so here this is the difference between this LT and NR frame structure. Now the frame, we will talk about this one more thing in LT and NR. One more thing we will talk about, that in NR there are two types of slot structure or communication, we can say. NR, we will say one is type A, another one is type B. So in type A, what happens, that it is the conventional, like the whatever frame structure we have, and we can use any subcarrier spacing 15 kilohertz, 30, 60 or 120, right? And here the communication with start with the slot only. So that is the conventional structure as normal communication in type A. Now in type B, right, we have a concept of mini slot. Mini slot, what is mini slot? Mini slot means, suppose this is a frame and we have here subframes we have. Now in subframes we have slots, symbols, sorry, right? In subframes we have symbols. So these are the boundary of slot. Suppose these are the boundaries of slot. Okay, so this is one slot, this second slot, like this, these are boundaries. Now mini slot is a concept where we can schedule any UE, right, in between the slot, in between symbol, any symbol of the slot. Suppose if there is a UE A and B, there are two UEs, and suppose this complete two slots are scheduled for UE A. So in the concept of mini slot, what happens, that out of these two slots, if UE B has got some emergency data means URLLC, ultra reliable low latency communication, has got some more urgent data, then we can schedule these in between slots to B, UE B, we can schedule. So this is the concept of mini slots. Mini slots means that suppose already these two slots are scheduled for A, but the B has more urgent requirement, then we won't wait for the boundary of slot. From that slot only we will we will stop the data of UE A and we will give UE B the data, because UE B has higher requirement or urgency, right, than A. So that is the concept of mini slot. So mini slot can be 2, 4 or 7 symbols. This is the, the size of the mini slot could be 2 OFDM symbol or 4 OFDM symbol or 7 OFDM symbol. Okay, this is one more difference between LT and NR. This thing you have to remember, that what is the main difference, that first was that numerology, the subcarrier spacing is fixed in LTE. Okay, in terms of numerology, if we'll see, Okay, only 15 kilohertz is fixed, but in NR we have 15, 30, 60, 120 as well, and accordingly the size of the slot will vary, as I have shown here, right? So now if we see, and here this is the concept of type A and type B communication. So in type A it is the normal communication, and type B we have got some mini slot concept. So that is this is one way of reducing latency. So one way was reducing latency was, I mean, if I'll show you, so we can say that in NR, if somebody will ask you how the throughput is increased in NR, what is the reason that the throughput gets increased in NR in 5G than 4G? So what you can say, that there are few things which we have evolved in 5G NR which are not in LTE. Out of those few things, one is numerology. Second one is concept of mini slots. Third one, I mean, there are many more are there, like I'll explain those in coming sessions, not today. Fast hark is there, the concept of fast hark is there. Flexible bandwidth part, BWP we call, flexible bandwidth part is there. Fast hark is there. After that you can say network slicing is there. So that is the different things I will explain later. So today I have explained these two concepts. Okay, now if we have to summarize, so we can say that in LTE and NR, we will make a table here differentiating these two. One frame is 10 millisecond, 10 millisecond, same in both. Okay, one subframe, 1 millisecond, 1 millisecond, same. Now slot, now not slot, we will take subcarrier spacing, SCS, subcarrier spacing, it is fixed 15 kilohertz, but in NR it is 15, 30, 60, 120, 240, like this. Now slot size is 0.5 millisecond here, and here it's dependent on subcarrier spacing, and one slot has 14 OFDM symbols. That is the fix here. So this is the one difference here. Here it is fixed 0.5 millisecond, but here it dependent on SCS, this one, and it will have 14 OFDM symbol. So as I showed you here in this part, that if the subcarrier spacing is 15, then it will be 1 millisecond. If it is 30 kilohertz, it will be 0.5 millisecond. If it is 60 kilohertz, it will be 0.25 millisecond. If it is 120, it will be 0.125 millisecond. Okay, so this is the you can say the concept here in terms of frame and numerology. This is the concept of numerology. So and the differences between an LT and NR. So that's it. So we will take further topics like fast hark and the ways how to reduce the latency, the concept of quality of service. It is different from LTE in 5G. So we will explain those things in our further sessions. So hope it would be useful for you. Thanks guys.